Hello friends, so today we are going to solve this problem, longest increasing subsequence. Okay, so the statement of this problem is given an array integer and then returns the length of the longest increasing subsequence. So what is the subsequence? Subsequence is given here is that create a subsequence from this array or sub array without changing the order of the elements. For example, from this array, we can have a sub-array, we'll call it as a subsequence, having a number without changing the order of the elements, like 3, 6, 2, 7. So this is 3, 6, 2, 7. There is no other way around, like 3 will come and then 0 will come. No. So if 3 has come, so then the sequence of elements in the array should be same in the sub-array also. Okay, so there is a one example also here. So with this example, we'll start our approach of solving this problem. Okay, we'll go to the pad. Okay, I'll write the same number here. Okay, so it's given 10, 9, 2, 5, 3, 7, 1, 0, 1, and 18. Okay, sorry for my bad handwriting. No problem. So it is telling to create a sub array. Okay, I'll start from the 10. If I choose the 10 here, what would be the next value? So next value should be increasing. So it's a increasing subsequence, right? So increasing, so it should be more than 10. So what is the more than 10 here? So 101. Okay, 101. Now, what is the more than 101? So nothing is there. So this is one of the sub-array with the increasing subsequence. So this is also, so what is the length? Length is equal to 2. Okay. There is another possibility here is that I can have a 10. In place of 101, I can choose 18. That is also a valid increasing subsequence. However, length is same, 2 only. Okay. Now, we'll take the another one. Okay. Okay, I'll take the 9. Okay. We'll create a subsequence. It should be increasing subsequence. So we'll look at what is the next element should be a part of the subsequence. So that element should be more than 9. So more than 9. So here again 101 is the more than 9. So 101. So length would be 2. Or similarly 9 and 18. Length is equal to 2. Okay. We look at the next element. Let me just change the color. Okay. We'll look at the next element. We'll take from the 2. Okay. So now 2. After 2, what should be the value? The 5. Correct. I'll take the 5. Now we'll look at the value more than 5. So more than 5, we have 7. Okay, we'll take the 7. And after 7, we have a 101. 101. What is the length? 4. Okay. However, we can have another way also, another set of numbers. 2. I'll not choose the 5. I may choose the 3. This is also valid increasing subsequence. 2, 3, then 7, and either 101 or 18. Okay, so length is equal to 4. Similarly, we can choose the 2 and 7 and then 101 or 18. So the length would be 3. However, with all these combinations, we can finish the 2 and then similar things we can do for 5 and 3, 7, 101, 18. And we'll have to find what is the length of the subsequence. Okay, and then finally we have to print the maximum, right? That's the maximum length. That should be the maximum of all these lengths, what we are going to calculate. Okay. So answer what is given here for this problem is 4. The maximum is the 4. And what is the subsequence here? So 2, 3, 7, 101. How can be 2, 3, 7, 1, 18? So this is the 2, 3, 7, 8. Now this is the subsequence, right? So there is another example here given. This good example for understanding. Okay, so this is 7, 7, 7, 7, 7. So what would be the subsequence? Increasing subsequence here. I'll take a 7, then I'll not find any number which is strictly greater than 7, right? So there would be only one number here in this array. So what would be the length? Length would be only 1. Hope now it's clear, right? What is the subsequence and then increasing subsequence. Now, we'll just go back to the same example again. Okay, so I'll rewrite here with the given set. So we have given 10, 9, 2, 5, 3, 7, 1, 0, 1, and 8, 1. Okay. Now we have to create a subsequence. How we will start? At the beginning, nothing is there, right? So we'll start from 10. So I have taken a 10 over here. Now there's a 9. So we'll compare this n, I'll call it as a n, with the last value of the subarray. Okay, so basically what I am telling is write down here. So compare if the subarray's last element, okay, if it is lesser than n, then only you band with the n, right? Okay, if not, that is the case here, n, so 10 is not the smaller than n, then what we will do? So see here, we are talking about the increasing subsequence, right? So the value should be in the increasing order. Let's see, this is sorting order with the increasing value. So we should think that, can we do some sort of binary search here? We will just give a try if possible. Okay, so now it's n has to put in somewhere where it should be put. What we'll do the binary search for the value which is greater than the smallest greater number from the 9. Okay, and then we'll place this value. So what I am telling, to find the index, okay, find the index in the subarray, okay, which is uh, which is smallest one but greater than this given number. Okay, so here in the subarray, suppose we have a given 10, and then we have given 11, just an example, we have given 12, and then okay, suppose just I'll take the, okay, suppose we have given 14 and we have given a 16, and value is somewhere 12. So what we'll do, we'll find out the value which is greater than 12, and it's the smallest value. So greater than 12 we have a 14 as well as we have a 16, but which one is the smallest one? This is 14. Okay, that's what I mean. So find out the index of this number and place it there. That's what. So I'll come on the coding part later, so just understand here. So 9. Okay, so with this subsequence, this is the index, right? There's only one index which is greater than 9, so we'll replace this part. Now it's a 9. Now next item is a 2. Okay, so 2. So again, 2 and 9. 9 is greater than 2, so we cannot add here. But however, what we can do, we will replace this with the 2. Okay. Next is a 5. 5 is greater than 2. Yes, we'll take 5. Now 3. 3 is greater than 5. No, we cannot take. Now what we'll do? Now we again do the same thing with this sub-array. Now we have two items. We'll find what is the place of 3. So 3 is greater than 2, right? And 3 is smaller than 5. So this is the place for 3. This is the place. What we'll do now, since 5 is greater than 3, so we'll replace this with the 3. Okay. Next is a 7. 7 is greater than 3. Yes, this is fine. Next is 101, which is greater than 7. Yes, this is fine. Next is 18, yeah, which is not a greater than 108. So now again we'll do the same activity. We'll find what is the place of 18 in this array. We'll do the same kind of binary search. Now see, these values are increasing value, right? So binary search can be done easily. So 18, we can find out what is the mid value here, and accordingly we'll shift. So the 118 place would be somewhere here, right? So we'll check what is the next value. Next value is greater than 18. Yes, so we just replace it, right? So, so basically, what would be the array? Sub array we will have. We'll have a 2, then 3, and 7, and 18. And what is the length? Length is 4. So this is the maximum. Good. Now we'll come on the coding side. What I mean to say here. So, well, I'll write the code. It will be better understanding. Okay, I'll just do it here. So just define the sub array, okay, and we'll iterate on the given array. So for n in nums, so initially sub array is empty. So if length of sub array is equal to 0, or the last element of the sub array, if it is smaller than n, then we append the value in the sub array, right? If that is not the case, what we'll do, we'll find out the index, okay, primary search way in the sub array which is greater than n, the smallest one, right? Okay, basically find the smallest number in subsequence, which is greater than n. So once we got it, we'll check in the sub array if this value is lesser than n. If yes, okay, so if this value, sorry, if this value is lesser than n, then in the sub array, let the idx plus 1 is equal to n, right? Because then this value would be lesser than n, so it will be increasing subsequence. If that is not the case, what we'll do, we'll just replace idx is equal to, right? That's fine, and then return the length of subsequence. Now we'll see about this binary search, right? So this is simple binary search. We'll call it as a array, and this is a number. Okay, we have a start index is equal to 0. We have an index is equal to length of array minus 1. Okay. We'll run the while loop when start index will be less than end index. Okay. Sorry for my spelling mistake. Good. Now we'll find out the mid index. Mid index is equal to start index plus end index minus start index 2. Good. We got the mid index. Now, if array of mid index it is less than n, that means n is on the right side, right? If that is the case, then start index will be mid plus 1. Else if array of mid if it is greater than n, so that means n is somewhere belonging to left side, and index equal to mid minus 1. Alright, if it matched, then start index equal to mid, and we'll break it. And what we'll do, we'll return the start index. Okay, we'll just look at once. We have created a sub-array and then we are iterating the numbers. If length of sub-array is equal to 0, add the number, or if the last element is smaller than n, append the number. If that is not the case, find out the smallest number in the subsequence which is greater than n. Okay, subsequence which is greater than n, and if subsequence of idx the num is lesser than n, no problem, that's good. So we'll just add the n on the next index. If not, if that is not the case, then we will replace with the number. And since it is asking the length, so we are returning the length. We'll run this and see. Somewhere n is not defined. Oh no, we have taken the number everywhere. Okay, number, and then it's number. Okay, run it. Yeah, all test cases are passed. Submit this. Good. So 94.57. Yeah, that's it. Thank you very much.